Hey guys, I'm going to try to do a quick little video here for you using Zoom this time, recording a meeting. And in order to show what we need to know for project number 3 of the Lathe portion of class. All right, there is a couple changes that we got to talk about in our formatting for programming a CNC lathe. Your first example, of course, was a CNC mill, and we utilized a sub-program. And the sub-program is a form of program reduction. On a lathe, lathes use can cycles a whole lot, okay? And that's because there's a lot of things on a lathe that are redundant. Peck drilling cycles, OD roughing cycles, boring cycles. Okay, all those, if you remember back to your days of running manual lathes, all right, and specifically if you're following the classes within the Camden County College series of classes for precision machining technology, remember back to the flywheel for the air engine. When you had to make that boss on the flywheel, there was repeated turning operations, all right? Repeated turning operations to make the shape. Now I'm going to share my screen. I threw the shape that we need to make into Mastercams so I could show you what a roughing cycle looks like, okay? So let me share my screen. So here we are. Here we are. Let me turn off the view of the toolpath. There's our shape, okay? That is the shape that we need to make. And let me jump over to the notes real quick. All right, short program lab 4. You need to correct a program that I have given you. It has errors and omissions, all right? What is left out of the program is the definition of profile used by the can cycles that are in the program. The can cycles that are utilized are the OD roughing cycle and the OD finishing cycle. All right. So having thrown this short little definition, this short little profile into Mastercam. All right. And that's just to show you what OD roughing looks like. So I turn on my OD roughing. All these passes, all those blue passes are feed rate cuts. And then the tool needs to back off and wrap it back to make another pass. That's the way we rough in a shape, okay? Without the OD roughing cycle, we would have at every inflection point that you see these blue and yellow lines, we would need a block of code. That's a lot of blocks of code, okay? But we don't need to do that because we can utilize the OD roughing and finishing cycles, all right? So the OD roughing and finishing cycles utilize the definition of profile. And we need to determine that definition of profile starting with the point that is the smallest and the closest to 0, 0. I just turned on, I'm using Mastercam, so I hit F9. F9 turns on the origin, okay, so I can see the origin. You can see it almost blends into the little line here on the end, all right? So that's why I had it turned off. So the lower right end of my part is 0, 0. So that is going to be the beginning of my definition of profile. And then all the way up here, the right end point of the definition of profile, that would be my end. All right. So if I was to put some letters on here, where's my drafting? Drafting. I don't use drafting all the time. All right, let me just use create letters. That'll work for me. All right, so we consider A being our first location, okay? Then I would need to make positions of B. All right. B would be right there. All right, and then C would be right there. And then we would need a D would be that position there. An E for here. An F. F hides, okay, a little bit. All right, you have to realize that you need a position right here. Oh, hit the arc. All right, why did it do that? And then we'll figure out why that did that soon. All right. And G. Now I'm stuck. Now I'm stuck with rotation angles because I got too close to an arc. Ugh. Newfangled products. Always got to change stuff on me. Okay. You get the picture, but I have to make it to the end now. All right. H being the last point right here. Okay. We don't need the left end point. The left end point of that line is not necessary. Okay. More than not necessary. It would make your definition of profile wrong for the OD roughing cycle. All right. So 1, 2, 3, 4, 5, 6, 7, 8. 8 points to define the definition of profile for this part. Okay. All right. So utilizing this print, you need to define the ordered pairs that make up those inflection points, endpoints, inflection points, points of tangency, whatever you need. Okay, so let's try to use a whiteboard now. Let's go back and stop sharing screen. I think that'll be my easiest way. All right, and then I'm going to share a whiteboard. Okay, and I'll use a text tool. All right. G71. G71 is your roughing cycle. G71 uses a P, a Q, a U, a W, a D, an F, and an S. Yeah, by far, this is the most needy G code that we have seen. All right. So what is P? P is the beginning line number of the definition profile. Q, ending line number of definition of profile. All right. U, we didn't talk about U yet. I will, but let me just say it right now. U is the incremental allowance, spelled wrong, true, incremental allowance in x-axis. W is the incremental allowance in the z-axis. Okay. D is your depth per pass. All right. F is your feed rate. And S is your spindle speed. Now, you don't need the spindle speed or the feed rate if you're in a feed rate and your spindle is turning before you get into the can cycle. But you can change them even if your spindle is spinning and your feed rate is specified for other portions of the program. You can specify them again here to change them to what you need. All right. Now, what do I mean by incremental allowance? All right. So we've been discussing some of the changes between a mill and a lathe and the difference in programming. Right now, you understand G91 is incremental positioning and G90 is absolute positioning. All right. Well, this machine, not because we're in front of a lathe, but because this machine has a different series of commands, it's still the RS-274D format of M&G code. All right. But it doesn't support G90 or G91. Remember, G90 is absolute, G91 is incremental. But on this machine we're in front of, because the builders thought it would be important to be able to mix absolute and incremental positioning on the same block of code, and we're right with that, we can do that because whenever we specify an X or Z, we're specifying an absolute position. Whenever we specify a U or W, we're specifying an incremental position. All right. So by using U and W in this OD roughing cycle, we are telling the machine to leave that real number worth of material on the diameter or on the length for a finish pass. So it's an incremental allowance for a finish pass, U and W in this case. All right. All right. P is going to be a block number. It's going to be an N number that is in the program. Q is going to be an N number that is in the program. Okay. All right. And D is your depth of cut. Okay. All right. So to talk about the finishing cycle now, G70 is the finishing cycle. It also uses a P and a Q. But of course, it's a finishing cycle. You want to finish it to size. So it doesn't use a U or a W or a D for that matter. So just G70, PQ, a change of feed rate if you want a finer surface finish, and a change in spindle speed, which may be increased. All right. You might want to go a faster surface feet per minute. All right, on the finished pass in order to because you're on smaller diameters. Okay, so that is the definition of a can cycle. All right, the OD roughing can cycles, and they're pretty much all the same, whether you're doing ID work, OD work, grooving, all right, roughing, finishing. They all utilize a definition of profile. Okay, so now this definition of profile, and let me go back to the semester long notes for this one. All right, semester long notes. Need to change. All right, why can't I see it? All right, here we go. Rotate it. All right. Notice that the G71 has the P140, Q180. All right. Not saying you need all those lines. Maybe you do. Maybe you don't. Maybe you need more. I'm not trying to give away all my answers. All right. But the definition of profile has to fall in between the roughing and the finishing. That part is correct. Okay. So we are correct in the location of the definition of profile. All right. All right. Notice the G50 is blank, so you need to use your G50. All right. So that's something you have to add. But other than that, there are other errors. All right. So your charge is to complete that part, all right, with this bogus program. Okay. And of course, I'm here to help you when you get here. All right. So some other idiosyncrasies of a lathe. T0101. All right. That code right there is how we call a tool, change a tool, and invoke an offset. All right. Reason being is our lathe is a turret machine. It's not a machine with a tool changer. So like a turtle carries its shell on its back everywhere it goes, the turret carries all the tools everywhere it goes, but you can only use one of them at a time. Okay. So the T01, the first set of numbers, that is the tool number. All right. The second series of number, that is the offset number. All right. First two digits represents the tool. The second two digits represents the offset number. So I could actually call a tool with no offset, T0100. That's an example of me calling tool number 1 with 0 offset. And that is necessary on some machines, all right? Because you have to understand how the machine is set up. And whenever you get to a machine for the first time, no one ever knows how the machine is set up until you use it, until you study the parameters. These little yellow lathes that we're using, the parameters are set such that the offset will be invoked before the tool change. So since we're changing tools at the home location, it causes the machine to over travel all the time. All right. So calling the tool with 0 offset at home is necessary. And then staying true to my rules for beginning programmers, always invoke offsets on the move. A T0101 with an X move and a Z move would be necessary because we have to invoke offsets on the move. It keeps you from over traveling. All right. The X and Z represents the position you're moving to, so the machine could do its math and say, all right, while I'm invoking the offsets, I now know I need to take the tip of the tool to that XZ position. All right. So that is always going to be in some clear location. All right. So let me try to change my screen share again. I want to go back to Mastercam. I don't see the ability to do that. So gotta stop the share again. Go back to Mastercam. There is a preferred location, not only, but not, I need to use the word worse, better than that. It's absolutely mandatory that you're in the right position in order to start a CAN cycle. All right, how can I denote that position for you here? Let me just put a little circle. Okay, so I'm drawing a little circle. All right, this little circle right here, okay, is the starting point. So when you invoke your tool offset in the program, it needs to approach this point, okay? That needs to be the starting location of your OD roughing cycle. Notice I put that location just a little bit higher than the maximum diameter of the stock and further in front of the stock than what is necessary, okay? So that point right there, your start point, is really important. So that's the point I'm going to suggest that you invoke your tool offset to in the part program. Okay. So I hope this helps, and I will be seeing everybody when you get in here. All right. With these series of lathe parts done, I do have what I consider a little treat. It's about the best I could do for you. All right. Project number 4 on the lathe is a chess piece. All right. You get all 3 pieces done here, which are what is required for class. Feel free to make a pawn. All right. There's a pawn program in the machine, and ask me for the number. I forget it off the top of my head. All right. And you'll need to set up the machine. You'll do your G50. You'll do your tool offset, and then the stock is already cut underneath the machines, and you can make a pawn. So every time you feel special, you could just look at that pawn and realize we're all just pawns. It's my instructor humor for today. All right, talk to you soon.